Hello, my name is Dr. Andreea Botezatu. I'm an assistant professor and enology extension specialist with Texas A&M, Texas AgriLife Extension Services. And today I will be talking about the influence of Flash Détente technology on the quality of black Spanish wines in Texas. I would like to start with a little introduction geography wise about the state of Texas. We can see the United States map over here. And if we look at the latitude of where Texas is located, we can see on this map here that it's located between the 25th parallel to the south, 26th parallel to the south, the southmost point in Texas, and the 36th, 37th to the north. To put that in perspective, this is a map of Spain, and the southernmost point in Spain is located on the 36th parallel. So the northernmost point in Texas, kind of on the same latitude as the southernmost point in Spain. We can see it here as well. So it's pretty south. We also have a coast here, the Gulf Coast here. So what happens is we have very warm days, very warm nights, and a lot of humidity, especially in the eastern side of Texas and the Gulf Coast here. And what that can lead to is a lot of disease pressure. And one disease in particular can cause a lot of trouble for wineries, grape growers here, and that's Pierce's disease. And for that reason, many of the grape growers, particularly the one on the east side of Texas and the Gulf Coast here, have to focus on growing varietals that are Pierce's disease resistant. And this is where black Spanish grapes come in. This is an image of black Spanish grapes here in Texas. So what is black Spanish? Black Spanish is a seedling of an American hybrid grape resulting from a cross of the American Vitis aestivalis species with an unknown vinifera pollen donor. Black Spanish is also known under different names such as Lenoir or Jacquez, and it carries natural resistance both to the phylloxera pest as well as to Pierce's disease, which I just mentioned, which is a very, very common threat here in warm winter areas such as Texas, especially with the added humidity. Black Spanish was introduced in Europe in the mid-19th century, where French vintners were intrigued by its similarity to European Vitis vinifera grapes, and they called it Jacquez or Jacquet. It became an important drug-producing grape in Europe during the phylloxera crisis, and it was later used to some extent as rootstock to protect the classic vinifera grapes from phylloxera. This is a chart of the varietals, grape varietals used by Texas wineries here in Texas. This is from the year 2018, and this is from a survey that I did on that year. So if we look here, we see the percentage of these particular varietals, percentage of wineries that use these particular varietals. So for black Spanish, we see that about 40% of the wineries in Texas use it. That's a high percentage. It is the 8th overall most planted grape varietal in Texas and the 6th overall most planted red varietal. Some of these are whites as well. And these are more varietals of grapes that grow in Texas, if you're just wondering. So taking a look at black Spanish wines, what are their characteristics, sensory characteristics? Most of them are very good. We have aromas such as black cherry, jammy fruit, elderberry, leather, tobacco. However, some of them, and unfortunately more than we would like to see, have this issue with a very particular characteristics that we, for lack of a better word, call it funk. And really this funk can be encountered both on the aroma, both on the nose of the wine and on the palate. So typically for a black Spanish wine, on the palate you would find spicy characteristics, jammy preserves, baking spices, tobacco, and every once in a while this funk that's really more like wet cardboardy, earthy, sometimes barnyardy type of funk. Color-wise, the wines don't have a very intense color, so the intensity of the color is low to medium usually. The hue of the wine is orange-brown with garnet notes, and the body usually is medium with low tannins. So what are the challenges with these types of wine? Like I said, the funk, which is chemical, medicinal, dirty, wet, cardboard, earthy sometimes. The color, we would like to see more intensity in the color, and the tannins and the body. So since life is too short for bad wine, we decided to look at ways of improving the quality of Black Spanish wines in Texas and processing them via Flash Détente technology sounded like a good idea. And we were hoping that out of this experiment, we will see that the Flash Détente treated wines will have either less or no funk at all. They would have better color and increased body and tannins. And then this is what we did. I worked with Bending Branch Winery here in Texas, as well as William Chris Winery. So Bending Branch Winery supplied the equipment and the labor. William Chris Winery supplied the grapes. And we set it up so that we had a control with no Flash Détente applied to it. So we had Black Spanish grapes, we had control, no Flash Détente, and then to that was applied the typical winery protocol. They call it the Enartis protocol. Treatment 1 consisted of grapes put through the Flash Détente technology with minimal processing, so no Enartis protocol added. Treatment 2, Flash Détente with the Enartis protocol added. All tests, all batches were run in duplicate, and each duplicate consisted of a ton of grapes, 1,000 kilograms of grapes. And the yeast used for fermentation was RP15. So let's look at the initial juice parameters. This is the juice for the control. Again, we didn't put it through Flash Détente technology. B1 and B's and A's are the treatments. So B is the minimal protocol, A is the Enartis protocol. Both A and B have been put through Flash Détente. So these are parameters for juice right after Flash Détente for the treatments. Control Brix 17.6, 17.3. We see a little bit higher Brix in the treated wines, so around 19 Brix, 18 to 19 Brix for the treated wines. For titratable acidity, it seems to be a little bit lower in the control, although this one stands out. Might have been a error of measurement. So 6.8 for B and 7.1 for the Enartis protocol. pH, quite a bit of difference here. The control stayed lower at 3.37, while after the Flash Détente, we see an increase in the juice pH to around 4 for both treatments. And then Yan, we see an increase in Yan as well for treatments as opposed to the control juice. And then fermentation was monitored throughout, twice a day. And we're looking here at Brix levels, slightly higher in the two treatments than the control here. And then they decrease as fermentation progresses. The Enartis protocol seems to be decreasing just a touch faster than the other two, but they catch up in the end. So pretty consistent overall. Ethanol follows the same trend, with the treatments appearing to, generate ethanol just a touch faster and higher because of the difference in Brix than the control. It levels off as the fermentation continues. Malic acid, pretty steady. It's lower in the control as opposed to the treatment, around 6 grams in the control as opposed to 8 in the treatments. That's at the beginning of fermentation. Stays pretty constant. And then around here, we noticed a steady decrease. This is when malolactic fermentation began, and malic acid starts its decrease. The slope is pretty similar for all of them. Volatile acidity starts lower in the two treatments. Of course, all of them are pretty low, so the highest is about 2.6. 0.26, sorry, my apologies, 0.26 grams per liter, lower in the controls, but as time progresses, it kind of levels off again, and it ends up with the highest VA of 0.72 in the Enartis protocol, and then the other two are lower. Just pointing out that this is where malolactic fermentation began. So once malolactic fermentation begins, we see an increase in volatile acidity as well. Overall, at the end here, it's around 0.7, so not hugely high, even for the highest one. pH values, this is juice stage, this is at the end of fermentation, and so we see a difference at the juice stage with the control having the lowest pH and the two treatments having higher pH, but towards the end of fermentation, they seem to level off somewhat, and so now at the end, they're closer to one another than in the beginning. Finally, after fermentation is complete, these are analysis for the finished wines. The control had a pH of 4.2 and the two treatments 4.3 and 4.3, so very close together. TAs are pretty similar as well, 5.7, 5.7, and 5.9. More chemical data, we looked at acetic acid, lactic acid, malic acid, tartaric acid, and total polyphenols, and this is the important bit here. Total polyphenols are the lowest for the control, significantly lower than both the Enartis and the minimal protocol wines, and the two of them, the two treatments, are significantly different between themselves as well. But this is the important part. So the control is much, much lower, as you can see, for total polyphenols than both treatments. And then we also have significant differences in malic acid concentration and lower differences, but still significant in acetic acid concentrations. Sensory, we ran descriptive analysis on these wines with a trained panel. The panel generated the descriptors for the wines, and then they were asked to rate the intensity of these descriptors on a 0 to 12 point scale, and these are the results here. These here that do not have an F before them refer to aroma, and the ones that have an F before them, in front of them, refer to flavor. So we can see that for the Black Spanish Funk aroma, the highest intensity ratings by far are for control, and then much, much lower intensity ratings for both treatments. Chemical medicinal, again, higher in control, the lowest in the wine treated with Flash Détente and the Enartis protocol. Same with Black Spanish Funk for flavor. We see the highest intensity ratings for control and the lowest for the Enartis protocol. Bitterness is higher in the control as well, and lowest in the Enartis. Fruit is about the same. Chemical medicinal, highest in control, lowest in the Enartis protocol, is a bit lower in the minimal treatment as well. So where we started with hope that this Flash Détente technology will help and reduce this funkiness that I've been talking about, we found that yes, it does decrease it, both on the aroma and on the flavor side. So that was very, very good news for us. Taking a look at color, this one in the middle is the control, so no Flash Détente done at all. However, this had the Enartis protocol applied to it, so no Flash Détente but Enartis, and this is with Flash Détente and Enartis, so notice the difference in color. This one is with Flash Détente and no Enartis protocol, so again, notice the difference in color between these and between the three of them, actually. Clearly, the control is the lightest, followed by the minimal protocol, and then the one with the Enartis protocol. These are intensity ratings obtained during the sensory evaluation of the wines. So the color was rated for intensity by the panelists, and the results show significant differences even that way through sensory analysis, with the highest intensity being for the Enartis wines, the next intensity down, the minimal protocol, and the lowest intensity for the control wines. And let's look at some volatile data as well. So I was intrigued by this funk character and trying to understand what it is and what causes it. I decided to run the wines on the gas chromatograph mass spectrometer here in my lab and try to see if I find any compounds that could be responsible for this characteristics. And I want to point out this image here. So this is the control wine, Flash Détente Black Spanish Control. And notice this peak here at 17.3 minutes. This is the mass spectra of the peak, and it has been identified as 4-ethyl phenol with 95% confidence. This is at 7.34, 7.34, 7.34. So 4-ethyl phenol in the control wine in Black Spanish. This was very surprising for me, but it makes sense because phenols, 4-ethyl phenol, 4-ethyl guaiacol have kind of these characteristics that we were seeing on the Black Spanish wines. However, we only associate these with Brettanomyces infections, and this was not the case here. So it appears that this particular varietal may be able to generate phenols on its own. The grape generate phenols. This is very preliminary data, so I would like to do some more work on this. But moving on to the treatment wines, so this was the control again. This is treated wine with Flash Détente technology, minimal treatment Flash Détente. We're looking at the retention time of 7.340, and there's no peak present for phenol at all. And these are the peaks that were found, no ethyl phenol in the Flash Détente treated minimal protocol wine. Same in the Flash Détente treated Black Spanish and Artist wine, same retention time, peak is absent. We look here, there's no 4-ethyl phenol at all. And finally, during the experiment, we sampled the water coming out from the Flash Détente machine. So we saved some of those samples and running the water on the GCMS. Lo and behold, here it is. And this, because it's water, the retention time of the volatile compounds will be different than those for wine. It's a different matrix, so the volatiles elute in a different different times. They have different retention times. So here's the peak for 4-ethyl phenol in the water coming out from the Flash Détente machine processing Black Spanish wines. Big peak. If you look at the abundance here, is over 150,000, which means this is a significant amount of ethyl phenol in the sample here. So what that means to me, you have it in the control, you have the ethyl phenol in the control, you have it in the water, you don't have it in the treated wines. Well, that indicates that the Flash Détente technology drastically reduces, if not eliminates completely, these phenols from the Black Spanish juice that is being treated. And to me, that's very important because we see similar effects with methoxypyrazines. So this technology can be used to reduce methoxypyrazines in wine. So clearly it can be used to reduce phenols in Black Spanish as well. And that is all.